Okay, welcome back. We're doing question 7. We have a height or a distance time graph. The graph displays the height of a drone above ground level after t minutes. Our variable is t for time and height for distance during a test flight. Okay, using the graph, so we're getting into the questions in part A. Using the graph, answer the following questions. Write down how long the drone was in the air. Okay, so time goes here, it went up in the air, it stayed in the air, stayed at a fixed height, hovered at a fixed height, went up further at a certain speed, hovered, and came down again. So it kind of went straight up and stopped at a certain speed, then it went up slower and stopped, and it came back slowly. So it actually just went straight up and down. This is time, not distance. The answer anyway is 5 minutes, because it started at 0 and went out 5 minutes. Time in minutes. The drone's ability to stop and hover in the air was tested during the flight. Indicated using the letters A and B, the sections. Now I just want to go back and see, do we know what the word section means, and we'll get that we'll get that in geometry, which is I think 2 pages on for coordinate geometry, or 1 page on. I think it's maybe 2 pages on. Or is it? We have to go back. We have to go back. Yeah. So in geometry, it's page 17. Because the reason we're doing this is I want to see the word line segment. Segment, it's a really important word. Oh, they do say sections, not line. I was thinking line segment straight across, but okay, the sections of the graph. Okay, a section of a graph, part of a graph, part of a graph, part of a graph, where the drone was hovering. So I'm going to put A along that line, that section, and I'm going to put B along that section, because that's where it was hovering. So that's where the answers go. Work out for how long the drone flew above the height of 15. Now the height's going up, so we're going to find out by putting a line across here at 15. Okay, now is it above 15 when it's at 15? No. Okay, for how long the drone flew above. So this bit doesn't count, so we're going from here. Now you'll always be asked here to show your workings. So you want to show your workings by coming down there, arrow out, arrow down. The other one, when you're getting a value, is arrow up, arrow over, but that's a different situation. And the other one we're doing here is this one, arrow down. Okay, so it started at 2 minutes, went down a minute, 2 minutes. Now how many sections are in here? 1, 2, 3, 4, 5, and here we have 3. So a fifth of a minute. Each one of them is a fifth of a minute, which is 12 seconds. So 1, 2, 3, 36 seconds. And 1, 2, 2 minutes and 36 seconds. 2 minutes and 36 seconds. Okay, a second drone. Oh, look, another one a bit different, with a kind of an orangey thing here. A second drone being tested, ascended. And we saw that word at the very first question. Ascending. And we said it's going up. So a second drone being tested went up. It'll have a positive curve. At a constant speed for 1 minute. So somewhere on this line we're going to be stopping. Somewhere here. And it ascended 25 meters, so it'll be up here and straight across from 25. So I'll bring across my 25 and I'll bring up my line here, and that's where they meet. Okay, so we have to do a second graph. That's the first section of the second graph. It hovered for 30 seconds. That's half a minute. 1, 2, 3, 4, 5. So 2.5 boxes to there. After descending, it hovered for 30 seconds before descending at a slower constant speed, reaching ground level after another 2 minutes. So it's here and it's got to go forward 2 minutes. So it's got to go forward 10 boxes. Right now I'm here, so I know it's going to be on this line after 10 boxes. So let's go forward 10 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it'll end up in there in the middle. So I sometimes put a dot with a circle around it. It's a way of really making a clear dot. Okay, and I'll draw that up there. So this is the second drone. On the given, draw a graph to show the height of the second drone above ground level after T minutes using the same axes and scales. Well, I've done that. Okay. Work out the average speed of this drone during its descent. So we can get the speed. Speed is distance over time. So the distance is going to descend is 25 meters. And the time it took to descend, it told us anyway up here, it took 2 minutes to descend. Hovered for 30 seconds and it took 2 minutes. So, and now did it give us any units to use? It didn't, funny enough. But okay, let's say 2 minutes is 2. And we'll be measuring in meters per minute. Okay, that's equal to, we can go 12.5 because the decimal goes in easily, or we can leave it the way it is, but 12.5 meters per minute. Yes, you could go per second, it would be much, much smaller. It didn't say correct to 1 decimal place, but it isn't that just it's not just correct to 1 decimal place, it's exact, isn't it? Because it goes in equally. So it's a bit misleading. The blades on each rotator do 150 full rotations every second at this speed. Work out how many rotations they will do in an hour. So 150 in a second. Let's bring it up to a minute. And let's bring it up to an hour. So I just did that kind of by inspection, by thinking along through it. I think I'm right. Every second, how in an hour, so to the minute to the hour. Okay, so our calculator, and I will do, we haven't done this yet in class, but we'll figure it out, and some of you might know how to do it anyway. So 150 multiplied by 60 multiplied by 60 equals 5400. But so first I'll write that down. 54 with 4 zeros. So the way this what they call standard form works is that you move the decimal place always so that this number is between 1 and 10, like it says there. So you move the decimal place to here. Now I've moved it 1, 2, 3, 4, 5. So so this is equal to 5.4, and because I've moved it 5 places, that's to the power of 5. Okay, you've got your number here that's between 1 and 10, and then you've got your natural number power here. So that's full marks for there, but I might want to do units on it. So it's this number rotations in an hour. You probably don't need to, but no harm in saying it. Rotations in 1 hour. Lots. That's probably the end of that question until we correct it. So before I move on, in question 7 we're going to get 35 in total. Okay. The first 3 are piled together, worth 15. So if we get them right, we're going to get 15 for, and when I say the first 3, it's all of part A. This is going to be 15 marks. let's start with like this. B, the first two parts are going to be worth 10 marks, and C, the last bit, is going to be worth 5 marks. Okay, so let's go and see what our answers were. It's a long paper, isn't it? It's a long paper, a lot of work. Got to be moving quickly. Okay, we got 5 minutes and we got 2 minutes 36, 15 marks. We did a graph, up, over and down, perfect. Use your graph and draw a graph. 10. This is perfect, I think. Anything in their graph that we didn't get? Nope. 12.5, so 0.2. Ooh, yeah, but they did meters per second and we did meters per minute. They didn't say what unit to do it in. So this is a valid answer. Okay. You could divide that by 60 to get the per second, but you didn't have to, so that's full marks. I stuck to an easy unit because I had those units. I didn't say anywhere not to. I'll give them full marks for that. I guarantee I'll give you full marks for that. Okay, so, and I'll just double check that if I divide 12.5 by 60 so that it's per second, then 5 over 0.208. Let's shift answer that. 0.208. Yeah, sloppy. They didn't do that nicely. Okay, we're getting full marks. And then finally 5.4 by 10 to the 5. And 5 marks and 5 marks. So another 5 out of 5 here. Okay, 15, 25, 30, 15, 25, 35. Double checking. Where is it? 35. Next one's 30. Some smaller ones then out to the end. Okay. As always, we'll see you in the next one.